Alright guys, so in today's video, we are going to be taking a look at a sphere. A sphere is nothing more than a three-dimensional circular form that is symmetrical from any angle. A sphere, unlike a two-dimensional circle, will remain circular no matter what angle you look at it from. Remember that a two-dimensional circle, when you put it in perspective, starts to look like an oval. But a sphere, no matter what angle you look at it from, remains a sphere, remains a circle. So then how do I get this circle, this contour of a circle, to look three-dimensional? That's what we're going to be looking at today. I'm going to be showing you several different ways that you can take a simple circle on a flat piece of paper like this and give the illusion of a sphere through cross contours and through shading. All right, so the first set of cross contour lines that I'm going to show you are actually pretty easy. First, draw a circle. Try to get it as close to a real circle as you can. Then draw a line through the center, and this is a temporary line. This is not part of the cross contours, but what we're trying to establish is like the poles. So think of that as like the North Pole and maybe this one the South Pole. Then what you're going to do is you're going to use these and you're going to start drawing ovals, and you want to try to make them equal from the center line right here. And as you come down to the front part of this, they're going to get wider. So it's going to be skinny here, a little bit thicker here, back to skinny, right? And that's because these are going into the distance, right? So they have to appear to get smaller, and these are coming towards us, so they need to appear to get bigger. So it looks something like this. So if I was drawing the entire oval, it would feel like this. And then once I get past center, they're going to start getting a little bit narrow again because they're going away from us, because they're also going away from us in these directions. To figure out which directions the ovals need to be curling is actually very easy to do with this system. So I've established a horizon line. Remember that the horizon line is your eye level, so that's why it's often referred to as the eye line. And this vertical line here represents the station point, right? So imagine that I was standing right here and I'm looking here, and this is the center of where I'm looking at. If the sphere is above you, like this one here, then all of these ovals will curl downwards, right? Because they have to curve towards the horizon line. If it's below your eyes, then they actually curve opposite. They curve upward, again, going back towards that horizon line. If it's to the right of you, then it curls back towards your station point. So in this case, it's curling to my left. And obviously the last one, if it's to the left, then it curls to the right. So think opposites. If the object that you're looking at is right smack in the middle, then anything above the center line will curl down, and anything below the center line will curl up. Anything to the right will curl to the left, and anything to the left will curl to the right. Okay. The second way of adding cross contours is to go to the poles. So here we're going perpendicular to the poles. Here we're going to go towards the poles. So imagine this is our imaginary center line right here. And imagine that these lines, the cross contours, are starting at the poles, or actually going behind the poles, and then they're going to curve around the ball and disappear at the other pole, just like so. Okay? So the widest part is going to be here, because this is the part that's coming towards you. And as they go into the distance, they'll get skinnier. So it'll look kind of like this. It's kind of like when you open up an orange. You actually can see this pattern right here. Okay? So skinny here at the poles. If it was see-through, you would actually see the entire thing. Okay? But we're not making this one see-through. So we're going from the poles around the ball, or the globe, or the sphere, and then back to the other pole, okay? If it's to the right of center, then you go in the opposite direction, going around, thicker here, right? Because this is the part that's getting closer to us, and then skinny as it goes away from us. Now this can be done vertically or horizontally or diagonally. Now let's say that I want the poles to be going at an angle and I don't want them to come all the way to the edge. So we can imagine that this being one of the poles and it's going to come out that way. In this case, what's going to happen is this is going to feel like it's going around this way and then disappearing at this pole. Same here. So it's going to go around this way. And that doesn't matter which direction you go to, as long as it's crossing here and disappearing somewhere in here. Because imagine if this was going all the way around, that's what we'd be looking at. The third method that I want to show you is just a combination of both, which in my opinion is by far the most useful one. So again, I'm going to establish the angle that I want my center line to go. And then I'm going to go ahead and start with this one, with the parallel one. So I'm going to go ahead and turn my paper here for a minute. And I'm going to go ahead and start putting in my parallels. Remember to get bigger here. And even though they're parallel, they will appear to get smaller as they go back into the distance. And then we're going to be doing the ones that go to the poles. Here's the pole. Here's where it comes out. Remember, anything on this side of center is going to curl to the left, and anything on this side of center will curl to the right. So imagine this going around. Whoops, it's a little off. And the reason that I feel this is the most useful one is because this gives you the most information when you have to use it to do other things, like when you want to add shading, when you want to add texture, when you want to add patterns. Okay? So as you get better and better, you'll be able to visualize most of this in your head. But as you're learning it, it's better to go ahead and lay it out. Okay? So you can see this area here is the biggest area because this is the part of the ball that's closest to us right here. And then because it's in perspective, as it goes that way and this way, it gets smaller. So it gives that illusion of three-dimensionality, even without the shading. The other way of transforming a circle into a three-dimensional sphere is through the use of shading. And as we know, when we do a shading on a three-dimensional object or a three-dimensional ball or a three-dimensional sphere, that we have to curve the shadows, and they have to curve according to the light source. Let's use this one here to show you how to use cross contours to help you with the shading. Okay, so if you have your cross contours in place and they are correct, then you can decide where you want that light source to be, and then use your cross contour lines to tell you where the shadows are going to be. So for example, if I put my light source over here, then I know that this shape right here is probably where it's going to be the highlight areas here. Okay, as it's going down in this direction, it's going to start to get darker. But also as it's going this way and this way, it's going to get darker. Okay. Now let's say that I put my light source on this side, then everything will change. So this area here will become the hot spot here. This will have a soft shadow as it's going into the distance. And then as it's coming this way and this way, it's going to get darker. So let's go ahead and use this. So keep in mind that cross contour lines are guidelines. So I drew them dark for the purpose of demonstrations, but if I was doing this for an actual drawing or a painting, I would make them extremely light, okay? Now the key is make sure that you use them, right? So as I'm putting in my shadows, once I start building up my shadows, I'm actually going to follow these directions. So here's like a transition, and then when I get to this side, they're going to start coming, flowing with this cross contours, with these curves on this side. Here they're coming this way. Keep in mind that my light source is here. So I'm thinking that my highlight is going to be here. And it's not going to be like a perfect square. It's going to have a little bit of a shape as well, right? And my cross contours are actually telling me that, okay? So here, coming this way. And then these are coming this way. Soft here. Okay, so that's my first pass. So I got my highlight and a light tone. Now, the cross contour that was here, roughly near the center, will actually tell me where that core shadow is going to start to be. So this is where it's going to start to get darker because the light can't get to this area here. There's going to be a little bit of a reflective light that's bouncing off perhaps a wall or something, but it's not going to be very bright. So here, I'm curving this. And I'm bending this, following the strokes established from my, by my cross contours. Now here I'm going to get a little softer to indicate that there's a reflective light. And then here should be the darkest shadow, which is that core shadow. Making sure that I'm blending. And I feel like this area needs to be a little bit darker here. Not as dark as this, but it is starting to go under the sphere, so it's got to get a little darker. And then brighter as it comes up towards the light source. So that, very easily, through the use of cross contours, I was able to very quickly, very easily figure out what my highlights and what my shadows were going to do, how they were going to bend, okay? Because it's not just your shadows, it's also your highlights. So it'll look kind of like that. Now, if there was a cast shadow on the ground, then that would not bend, right? We're assuming that this is a table or something, and that is flat. So in this case, the shadow will become an oval, just like that circle became an oval when we were working with the cylinders. Remember that the darkest part of the cast shadow is going to be where the two objects meet, the table and the sphere. And then as it starts to go away, you can pretty much imagine that some of that shadow or some of that light's going to get through, and it's going to brighten it up a little bit. Remember not to outline a cast shadow. So there you have it. So my recommendation is when you are learning how to take a basic circle and turn it into a sphere, I would actually recommend that you do it through the use of cross contours. Master different angles and different directions that you want to use your cross contours in. And then use those to do your shadow work, or textures, or lettering, or patterns, or reflections, or anything you want, okay? So when we look at this lithograph called The Balcony by M.C. Escher from 1945, you can clearly see right here that there is a sphere. And then he used cross contours to alter the walls, the angles of the buildings to make the buildings look, or the balcony look, like it is going around the sphere. Here in Hand with Reflecting Sphere, you can see that he used cross contours to create the reflection onto a three-dimensional sphere. So there are virtually no straight lines here. Everything's curving. The walls are curving, the furniture is curving, the bookshelves are curving, and he was able to accomplish that through the use of cross contours. All right, so that'll do it for this week's episode. Next week, we're going to look at how to transform these three basic forms and how to combine them to make more complex forms. Until then, I will see you. Thank you so much for watching, and I will catch you on the next video.